Good morning, everyone. Good morning. Hope all is well. All right, look, people still trying to connect, so let's go ahead and give them a chance. Oh, thank you, thank you. I appreciate it. All right. Everybody good? I still got a few people come. Oh, somebody unmuted. Somebody has something to say?
Yes, I said good morning.
Good morning.
And I'm sorry about what happened. I just saw the video that you
Oh,
posted.
oh, thanks. Appreciate
And
it.
I was like, are you serious? Like, and you always answer my emails and like help. So I was just really confused on like why that happened. That's none of my business. So I was
Well,
like,
I
oh,
appreciate it.
really? Because you're
Yeah.
always like, oh, if you have any questions, come after class. Like, you can just say and email me. Like, I get back. And you're good on getting back to emails because I've emailed you a couple of times.
Yeah.
And I was just watching it and I was like, okay, that's weird.
Well, I appreciate it. I thought it was a little different too. I didn't understand where it was coming from, but like I said, maybe it was more to it. I don't know. All I know is what I got from the dean. So, and I don't, like I said, I didn't know who it was or what class. So I just sent the email out. It might not even be this class. You know what I mean? So
Yeah.
I don't know, man.
Sorry that
So
that happened though. That
I
kind of
appreciate
sucks.
it. I appreciate it. I don't know. I don't think some people actually consider it a lot of times, just like, if you got a job, somebody go to your boss. It's just like, yo, that's your boss. Like, you know what I
Yeah.
mean? And, if I had a chance to rectify it or if somebody had brought it to my attention and I didn't do it, then I understand why you go to my boss. But,
Maybe they
my
were
whole,
just scared to talk to you about it or
it's
something.
possible. It's possible. It's possible. So, but it happens, things happen. So that's why I didn't want to send an email out because I didn't want people to think I was mad either.
Uh-huh.
And then you really be scared to talk to me, you know what I mean?
Yeah.
So and then be like, oh shoot, do he know it's me? Like, I didn't want anybody to think that either. So yeah, so that's why I had to shoot a little video out. But I appreciate it. I do appreciate that.
No problem.
So did anybody before we get into chapter 4 and start looking at graphing, I believe it's chapter 4. Yep, yep. Yep, chapter 4. We start looking at graphing. Anybody have any questions or concerns, comments, anything? Oh, hold on. My stuff is messing up.
Question.
Yes.
Okay, so for the test that we just took, well, and it's Sunday, I did it a second time, and I didn't send you the scrap, like of my answers. Are you holding that against me? Because I do have it. I could just, haven't sent it to you.
No, it's fine. I mean, at least you send it one time. That's good to go. You're fine.
Okay, thank you.
Now, I will say this: if it's something that you want me to look at, that's on, those scrap sheet or something, then that's when most definitely you need to send me, the latest copy. But if you're good, as long as you send me that one copy that showed me that you were doing the work and that you did the work, then we good to go.
Okay.
All right. Thank you for asking. Let's see. Oh, thank you. Thank you. I appreciate that. I appreciate that. Thank you. Let me see. Get this. See if I can pull my notes up. All right, here we go. So we're looking at graphing today. Don't forget that deadline was Sunday. If you had any issues getting stuff in by the deadline, make sure you shoot that email to me so we can put you on a plan to get caught up. Don't just take zeros.
I did. I sent you an email.
Yeah, I already responded back to you. Did you see the response?
Yes, I did.
Okay. I was making sure you saw it. Okay. Yeah, so you should be good. Let me know, if you have any other issues. But yeah, so yeah, most definitely when it comes to these due dates, guys, don't take zeros. Let's talk about a plan to make sure you're straight because we still have plenty of time. It's only week 5 to make sure that you're caught up and you have all your grades in. All right, so looking at 130. Let's see, do I have the? Nope. Looking at my other set of notes. Okay, so we're just gonna have to go to 60, somebody else. Yes, that test review, you get if you score that 85 or better on your test review, you get 5 points added. Sunday wasn't the deadline for chapter 10. No, let me look and see what I said up there. No, Sunday was the deadline for those first 2 chapters.
Yeah. The deadline for test number 2 is, I think, October 3rd.
Yeah, and I need to adjust that in Math Lab. But yes, ma'am, you're absolutely correct. October 3rd. Yep, not a problem. All right, so 10.1. Hold on, it is 4.1 for you guys.
But
Sorry
if
about
it's
that.
below an 80, we don't get any test review points.
Say that again.
If it's below an 80, we don't get any test review points.
Yeah, the standard was 85. If you need me to open it up so you can get a few more points added to it, then I can. But yeah, so the standard was 85. But if you got like an 80, then you're close. So if I was you, I would just like do 1 or 2 more problems.
Okay.
Yeah. So if you need me to open it up, just shoot me that email and I'll open it up for you so you can go ahead and knock it out.
And my last question, I'm in my math lab and it says like everything else is due December 17th. Is that correct?
Well, we're going to adjust the score, adjust the dates as we get close to closing out the section. So chapter 10's content, we already said is going to be October 3rd. So I need to adjust that. So then when we get close to closing out chapter 4, I'll change chapter 4's content date.
Okay. No
Yep.
problem.
All right. So chapter 4, 4.1, we're looking at graphing. It says, when you look at it, it says scatter plots and graphing linear equations. We're not doing the scatter plots. It's just that's the title. They had other stuff in there. You guys aren't held responsible for scatter plots. You're just doing graphing linear equations. So just want to throw that out there. When you look at that title, we're not doing scatter plots. All right. So the Cartesian coordinate plane is made up of 2 axes. Where they intersect will be your origin. And that origin is the coordinates of the origin is 0, 0. So you have your horizontal axis, which is your x-axis, vertical axis, which is your y-axis. To the right of your origin, all positive values. To the left of your origin, negative values. Above your origin, positive. Below your origin, negative values. Split up into 4 quadrants going counterclockwise. So that's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Once again, going counterclockwise. To get into quadrant 1, you have to make 2 positive moves. Quadrant 2, negative and then positive. Quadrant 3, 2 negative moves. Then quadrant 4, positive move and then a negative move. Now we'll be graphing by what we call ordered pairs. And they're called ordered pairs because the order matters. You're always going to do your X move first and then your Y move. So horizontal, then your vertical move. So you can think about X comes before Y in the alphabet. You walk and then go to the elevator, go down, I don't know, run and then jump. But it's always your horizontal move first and then your vertical move. Yep. Any questions on anything so far? Give everybody a chance to copy before I scroll up. Tucker, you still copying this graph, right?
I'm on the last little thing. I'm on.
Okay.
So you can go ahead and scroll.
Okay, cool. So I'm going to erase this stuff, guys, and then we're going to walk through it some. All right. So, make sure I got. All right, so we're gonna grab these 6 points, make sure we're good to go on them, and then put the location as to where they are. So when we look at 2, 5, once again, you always do your X move first, which is your horizontal move, then your vertical move. So we're gonna go +2, +5. So I will start at my origin. Your origin is right there. Always go to your origin, go to the right 2, and then up 5. That's right here. So that's going to be 2. Oh, 2, 5. So we went to the right 2, up 5, and that puts us in quadrant 1. All right. So for the next one, -1, -3. Start at the origin, go to the left 1, and then down 3. So that'll be right here. -1, -3. Oh. That puts us in quadrant 3. All right. Next point, -4, 2. Start at your origin. This time we go to the left 4, up 2. That'll put us right here. So it's -4, 2. So that puts us in quadrant 2. And for that fourth one, start at your origin, go to the right 1, down 5. So before we go to either one of those other 2, those last 2, is everybody okay with the first 4? How to graph. All right. So now we have 3, 0. So X is 3, Y is 0. So I'm going to go to the right 3, but I do not move anywhere for Y because it's 0. So that I don't actually end up in a quadrant. That's just sitting on the X axis. All right. And then for that final point, 0, 3, X is 0. So I don't move left or right, but then I go up 3. That'll put me here. Well, I didn't put my coordinates. So this one is 3, 0, but this one right here is 0, 3. And that puts me on the Y axis. So we're going to plot some more points when we get to the equations and everything. But any questions on these 6 points, how you plot a point, always start at your origin. If it's positive, you move to the right. If it's negative, you move to the left. Then if Y is positive, you go up. But if Y is negative, you go down. All right. So let's look at the next thing. Like I said, we'll come back to graphing in a second. But the next thing they talk about are solutions. So an ordered pair is a solution of an equation if the equation is true after the ordered pair is plugged in. All right. So let's look at this first example. We have 4x minus 3y equal to -2. and they give us the order pair 1, 2, and we want to know, is this order pair a solution of this equation? So don't forget, the first component is X, second component is Y. That will always be the case. And you plug them in accordingly. That means 1 for X, 2 for Y, 4 times 1 minus 3 times 2. 4 times 1 is 4, 3 times 2 is 6. 4 minus 6 is -2. So yes, it is a solution.
Oh, where'd you get the 1 and the 2? Is that a given?
From right here, yes, they will give that to you. They will ask you, is this order pair a solution of this equation? So yeah.
So what is that after the 2? But in the purple
Right
writing?
here,
Yeah, what is that?
a colon, a semicolon, I mean, semicolon. Dot
And
colon.
we got to input that. We got to put that in. Is that important for
No,
us to?
no, they give you the problem like this, and it's just to separate that this is your order pair.
Okay.
Yep. Let's see, somebody says in the chat. Can you scroll back up for a second? Tell me how far you want me to go up. Was that all you needed? Or you need to go up further than that?
So this don't got nothing to do with graphing?
Yeah, I'm about to connect it in a second. I was just, somebody else was copying something, so I was giving them a chance. I don't want to scroll up. All right. Ms. Bullock, I didn't get an answer from you. Was that high enough? I didn't know if I need to go up further. Or I guess we're good. Okay, you got to check. Okay, cool. All right, so let's scroll up a little bit. So connecting what your classmate just mentioned, we talk about graphing. So there are infinitely many solutions to a linear equation. And so when you have a point that's a solution to this equation, if you were to graph that line, this point will be on the line. So when you look at the line, and we're going to get into graphing lines, so every point on this line is a solution. So every order pair is a solution. Every order pair that's on the line is a solution to the equation. So 1, 2 would be a point on the line that 4x minus 3y equal to -2 creates. So that's the connection there as far as graphing is concerned. If an order pair is a solution to your equation, it is a point that is on that graph when you graph it.
You just threw me for all types of left loops. I don't get it. What?
Well, we are about to graph like stuff like this, and it'll give you a straight line when you graph it.
If it's true, it'll give you a straight line. If it's not true.
Well, let me say it like this. This line in general by itself is going to give you a straight line. It's called the linear equation. So when you graph it, it's going to give you a straight line. If this is a solution, that means it's one of the points that's on that line.
Okay.
You see what I mean? So there are infinite amount of points that make up that line. So 1, 2 is one of the points that make up that line. So that's what we're saying. Go ahead.
And 4 and 3 are another point on that line. I don't get. That's what I don't get.
No, because this is the ordered pairs are set up this way. 4 and 3 is a part of the equation. You see what I mean? The ordered pair is, now if it said 4, 3 with parentheses, then that's a point. But see, this right here is an equation. That's a whole equation. That's a whole statement. So you can't just separate 4 and 3 and make that a point. You see what I mean?
Right.
So your points are defined this way. Is parentheses number, comma, another number, that is going to be a point for you. This right here is just your establishment. That's your equation that the line is going to be created by.
Okay. All right, thank you.
Mhm. All right, let's do one more. This time to give us 2 points. We have, I think the way I had it before, I ran out of room. That's why it's over here like that. But we have y equal to 3x minus 5. And they want us to check 2, 3, and then 3, 4. So these are 2 separate points. You know, this is point 1, and this is point 2. So we have to check them separately. Once again, the first component, the thing that comes before the comma is x. Second component, the number that follows the comma is y. And so once again, you have to do your, excuse me, your substitution separately, 2 separate points. So 2, 3 is over here. You plug in 3 for y, 2 for x, and see if you get a true statement. So 3 for y, then we have 3 times 2 minus 5 on the right. 3 times 2 is 6. 6 minus 5 is 1. So 3 equal to 1 is not a true statement, you know, because 3 is not equal to 1. So that means it's not a solution. So 2, 3 is not a solution. In other words, that point would not be on the line that this creates. Okay. Turkey, you got a question? I see the face you're making.
So I'm just trying to follow along
Yeah, you fine.
and plug in the numbers as I go, like, so I can kind of understand it while I'm writing it.
Mhm.
But it's just plugging in the 2 and 3, checking it, and then plugging in the 3 and 4 and checking.
That's
and
it.
determining which one's true.
Right. And so when
Okay.
we look at 3, 4, notice that it came down to 4 equal to 4, which is true.
Okay.
And that's why that one is a solution.
I have a question.
Yep.
So as long as it's the same number on both sides, is always true. Is that what we're looking for?
Yes, exactly. Uh-huh.
Okay. Thank you.
Yep, not a problem.
So would the answer be, the answer is going to be not a solution?
Right.
That's exactly what it's going to say. It's going to say
Right.
not a solution.
It would it may ask you which is a solution, and maybe you'll just list, you know, my math lab will ask you different ways. It may ask you which is the solution. So in that case, you would type in 3, 4. Or it may give you a statement to click on, is a
Okay.
solution or not a solution, something like
Right.
that. I forgot how they ask you to answer, but if there's any confusion, you know, you can shoot me that email and I'll
Yeah,
make
for sure.
have
For sure.
Yeah.
And yeah, because a lot of times it's not the actual problem or the question that gives me a problem. It's the way that MATLAB puts the questions to me
Right.
that confuse.
Right. Yeah. So, we didn't talk before. We'll talk again. So yeah. Yeah. We'll definitely make sure you're straight. So can we scroll up before everybody good? All right. So when you talk about graphing these linear equations, and the key word here is linear. Matter of fact, I'll leave that. That's for another class. It was 10. This class has it as 4.1. 4.1. I think intercepts 4.2. Let me check real quick. Okay. Intercepts and slopes. Okay. So they put both of these in 4.2 for you guys. Intercepts and slopes. So the first method is using the XY chart, which is what we'll do in this section of 4.1. Then you can graph using your intercepts, which is 4.2. And also you can graph using your slopes. And from what I see, you guys have 4.2 as well. They put that in 4.2 as well. Normally they separate those sections, but it's all good. All right, so let's look at the first method, using or creating the XY chart in order to graph. Everybody got those methods rolling up? Okay, so I'll go ahead and do this. All right, so we have the equation y equal to 2x plus 1. And so you choose x values, plug them in, then find the corresponding y value. It does not matter what values for x you choose. Just remember, whatever you choose, you have to graph it though. So if you choose 150 and 1 million, just remember you got to graph those values that you're choosing. So I always choose something simple like 1 and 0, or something like that, something easy to calculate and check. Also, MATLAB only requires 2 points. I have a habit of doing 3 points because back in my day, we always did stuff, on paper, and we always had to do 3 points as a system of kind of checks and balances. So I always do 3 points. MATLAB is only going to require 2 points though. You cannot grab 3 points for your line in MATLAB. Once again, I always do 3 out of habit, out of how I learned how to do it. So notice I chose -1, 0, and 1. You could have chose 1, 2, 3. You can choose any values you want. Just remember, whatever you choose, you have to graph. All right. So we're going to plug those values in for x and then find the corresponding y value. So here I have 2 times -1 plus 1. 2 times -1 is -2 plus 1. -2 plus 1 is -1. So when x is -1, y is -1. Of course, that won't always happen, but that happened in this case. Next one, plug in 0 for x. 2 times 0, 0. Plus 1, 0 plus 1 is 1. So when x is 0, y is 1. And then the last point, plug in 1. 2 times 1 is 2. 2 plus 1 is 3. So when x is 1, y is 3. So before we go to graph, any problems with the points that we generated? Once again, you choose your x values, and then you find the corresponding y value to each x value that you chose.
And the point of this is to find out if all 3 of these lines are in one, all 3 of these points are in one line.
Well, no, if you do everything correctly, that will be the case. If you do everything correctly. So you're not trying to find out if they are, you're trying to find the points that will create this line. So the points that you generate will create this line right here, the line that represents this equation. And
Okay.
so, yeah, go ahead.
So that equation is equal to a line on a graph.
Exactly. Exactly.
And we just have to plot the points.
And then connect the points, and that'll be your line. So this line is a representation, a graphical representation of this equation.
Okay. And what we did on the right of that was just, yeah, what we did over there was
just the work. That's just the work to help
And we
you
could have,
get. Mhm,
and
go
we
ahead.
could have plugged in any number
Right.
and got the same
Line.
result.
Yes, and I'm about to show you why in a second. Yep.
Okay, all right. I'm
Just want
sorry.
to make. Oh no. I just want to make sure everybody's with us before I go there. But yeah, most definitely. So, what we would do is grab those 3 points. So you would go to your origin just like we did with those 6 points in the chart, but this time we should get a line and not just random points. So you go to your origin, go to left 1, down 1, and we get this point right here. Oh, then 0, 1. So you don't move left or right for X and just go up 1. And that's this point right here. And then to the right 1, up 3 is this point right here. And then like we just finished mentioning, talking with your classmate, connect those points and you get this line. And that's a graphical representation of that equation. So like I just mentioned, you could have used any points and you would have got the same line. So how's that the case? Notice I put these arrows at the end of each direction. That means it goes on to infinity in those directions. So if let's say if I said X was 10, or let's say 20, 20 would have been down here somewhere. And then when I find my Y value, it would have been up here, and that still would have connected to this line. And it still would have gave me the same line. It's just that it would have been further out. Same thing as if I would have chose negative 100, it would have been way to the left, but then it would have created a point that was way down here that still would have connected with that line and still gave me the same slant line. It's just that once again, that's why I said, whatever you choose, just remember you're gonna have to graph it. So it can be real crazy or it can be real small, and you can just graph that same line, have the same graphical representation. All right, questions before we do another one? Make sure we're all right. All right, can we scroll up? Everybody good? All right, so this next one, we have y equal to negative 3/5x plus 2. Oh, let me erase this so we can walk through it. So now you do want to be strategic when you choose your values and you're dealing with a fraction, because you don't want to have to graph a fraction if you don't have to. You don't want to have to graph a decimal if you don't have to. So here we have 3/5, negative 3/5, and we're going to choose values that are multiples of the denominator. And notice in the in the blue, numbers that the denominator can divide into evenly. So that's what we're talking about when we say multiples of the denominator, numbers that the denominator can divide into evenly. So notice that would be numbers like 5, 10, 15, 20, 25, 30, or negative 5, negative 10, negative 15, negative 20. These are just values that my denominator, which is 5, can divide into evenly. So let's say if my denominator was 7, then that means I'm going to use 7, 14, 21, values that 7 can divide into. If it was 11, then I'm going to use 11, 22, 33, 44, values that 11 can divide into. So all of this is based on what your denominator is. Then you're going to choose values that your denominator can divide into evenly. All right. Questions on that before we do the calculation? And so you see, I kept in the same flow of my -1, 0, and 1. I chose -5, 0, and 5. 0 is always a good one. That's always the easiest thing you can calculate with. So if you can use 0, most definitely go ahead and take advantage of that. Hold on one second. All right, so let's plug in -5. So right here, it's plugging in -5. Now, if you want, you could cancel out first. I decided to go ahead and leave it in fraction form just to show the whole process. So we have -3/5 times -5/1. Just multiply across. And that's +15 over +5. 15 over 5 is 3. 3 plus 2 is 5. So make sure we're okay with the calculation of what we did there. But notice how the fraction simplified evenly. All right, scrolling up a little. Doing the same thing with 0, plug in 0 for x. -3/5 times 0 is 0. 0 plus 2 is 2. And then for 5, plug in +5. Try to leave room. If I made it too small, let me know. So that's -5/5 times 5. That's -15/5, which turns into -3. -3 plus 2 is -1. So make sure we are okay before we look at the graph. All right, so once you have your 3 points, and remember, like I said, in Math Lab, all you need is 2. You graph your points and then connect the dots. So we have 5, 5, -5, 5, which is right here. So you go to the left 5, up 5. 0, 2, you don't move left or right for x, but go up 2. And then to the right 5, down 1, which is right here. And that will be your line.
Where's your 5, 1 on that graph? 5.
Talking about 5, -1.
5. Yeah. Oh,
Right
right
here.
there. Okay.
Yep,
All
to the
right, I
right
see
5,
that.
down 1.
Scroll up for just a second.
Yep, not a problem.
What is that? What does that say in the red?
Oh, that's not
For-
for you. That was for
Okay.
103. That's from one of my other classes. So, yep, sorry about that. Should have said something about that. Another class.
I gotta say,
Hmm?
when I looked ahead in this,
Mhm.
didn't have a clue as to what was going on. Now I got what to do.
Okay.
So
That's what's up.
yeah.
Cool,
It's
cool,
effective,
cool.
brother.
Okay, appreciate it, man. We'll look at one more method before we call it a day. Trying to make sure everybody got it before we move on, though. Let me know how far I need to go up. Look down low, what you need. Okay, not a problem. Let me know when you finish. All right, we good to go. Let's go straight. If we're good. If we're not good, I'm assuming you're gonna let me know. Everybody straight. People calling me. All right, so next method, we're looking at intercepts. All right, so if you remember the last 2 points when we graphed those first 6 points that we dealt with, remember one stayed on the x-axis, the other stayed on the y-axis. And that was because when we looked at the one that sat on the x-axis, we couldn't move up or down because y was 0. When we look at the one that sat on the y-axis, we couldn't move left or right because x was 0. So we have what we call x-intercepts and y-intercepts. Your x-intercept is where the graph intercepts or crosses the x-axis. In other words, that's the point that your line is on the x-axis. So whenever you have an x-intercept, there's one characteristic that is always going to be true, and that is y is 0. So for all x-intercepts, y is 0. Then when you talk about your y-intercept, that's where your graph crosses the y-axis. In other words, when your graph is on the y-axis. So for that point, x is always 0. So once again, for all x-intercepts, y is 0. For all y-intercepts, x is 0. Give you a chance to write that down. All right, can we scroll up? Okay, so we can graph by using these intercepts. And what we're going to do is hold true to the characteristic of each one of the intercepts. It doesn't matter which one you find first. Normally I find the x-intercept first, but like I said, it doesn't matter. So if we have this equation right here, 2x plus 3y equal to 12. Normally this type of method is used when both of these numbers can divide into this one evenly. You got 2 and 3, they both can divide into 12. Normally that's when this is used. You know, let's just say if you were doing it on your own. But the problems you get, of course, they would say graph using intercepts. But so what we do is, if I know I want to find the x-intercept first, we start off with the characteristic of all x-intercepts, and that is y is equal to 0. Okay. So if you let y be equal to 0, you plug in y into the original equation. So that's 3 times 0, and that is 0. Then that'll leave you with 2x equal to 12. And then divide both sides. Let's see if I can get it back. All right, I'm gonna worry about it one more time. Yep. Divide both sides by 2. X is equal to 6. So the coordinates of your x-intercept is going to be 6, 0. All right. Do the same thing for the y-intercept. It's just that x is going to be 0 this time instead of y. So you plug in x for 0, that's 2 times 0, which cancels out completely, leaving you with just 3y equal to 12. Then divide both sides by 3. Y is equal to 4. And then here, don't forget the position of your ordered pairs. Remember, x is first and then y. So this coordinate is going to be 0, 4. Because x was 0. Any questions? All right. Everybody good before we do it again? Oh, yeah, that's right. We have to graph it too. So if you graph those 2 points, go to the right 6. You know, for 6, 0, go to the right 6, but don't go up or down as far as y is concerned. That's 6, 0. So that's why we have that here. And then for that y-intercept, you wouldn't move left or right because x is 0, but then you move up 4. And that's how we got 0, 4. All right, any problems before we look at one more? All right, let's try it again. Everybody good? Can I scroll up? So we have 5x minus 4y equal to 20. Same direction, so same flow. Y is equal to 0 when we're trying to find our x-intercept. Plug in 0 for y. That cancels out that 4. It leaves us with 5x equal to 20. Divide both sides by 5. X is equal to 4. Gives me the ordered pair of 4, 0. And the next one, be careful. We're gonna let x be equal to 0 because we're trying to find a y-intercept. That cancels out that first term with 5. So that leaves us with negative 4y. Make sure you don't lose this negative right here. Sometimes people do that and they're, going through their steps. So make sure you don't lose that negative, because what we have now is negative 4y equal to 20. Now we can divide both sides by negative 4. That'll give us negative 5 for y. And then the ordered pair is 0, negative 5. Graph those 2 points. For your x-intercept, go to the right 4. And then for your y-intercept, you go down 5. All right. Any problems? Everybody good? Everybody? All right. And one last thing, and we'll close it out. We're looking at horizontal lines and then vertical lines. No calculation, just concept. But are we good? Can I scroll up? All right. So notice every equation we had up to this point had an x and a y involved. So now when we look at this next one, try to stop this thing. We look at this next one, notice it's just y. So whenever you just have that variable, it says that no matter what the other variable is, the variable you see is always that number. So notice it says y is equal to 5. That means y is always 5 and x can be anything. So no calculation. You can create any kind of chart you want. X can be anything, but y is always going to be 5 no matter what x is. And then what's going to happen is when you go to graph that, you're going to have a horizontal line at 5. So if I go to the left one, up 5, that's right here. 0, up 5 is right here. To the right one, up 5 is right here. Connect the dots, that'll be a horizontal line. So y equals no x, you don't see any x. Y equals to whatever number will always be a horizontal line at that number. All right. Any problem with that one?
Are we still creating the x, the numbers for x?
Yeah,
X can be anything.
it can be anything. Yep.
All right. So it's still same principle as when we first started talking about it.
Yes.
All right.
And then for vertical lines, now this one, just have to hold true to what we said. If you just see the one variable, that variable will be that number. And then the other one can be anything. So in this case, x equal to -2. X can't be anything in this case because x is equal to -2. So when x will always be -2, but in this case, y can be anything. And so what this will do is create a vertical line at -2. right. Questions, any questions on anything? Everybody good, everybody straight? Mhm. Okay, so that's it for today. Next class, we'll get into slopes. And that'll be our third way of graphing these lines. And go from there. All right. I heard somebody unmute. Are we good?
Yeah, I got a question not pertaining to this,
Okay.
just pertaining to what I asked you about one time before, that about the parentheses and the like exponent. Like,
Okay.
so because I remember I still got that problem wrong on the test or whatever. So like, what's a real dumbed down simple rule that I can just take with me and use for that? Just
Now, so I just want to make sure I'm clear on what you're asking about. So you're talking about, let me see a good one. Are you talking about involving negatives?
yes,
Okay.
yes,
And the effect that an exponent will have on. So
yes.
basically is, well, this one would be good because it's to the fourth, let's go to the fourth power. Basically, parentheses incorporates everything. No parentheses is the only thing that's right up against it. That's the only thing that's affected by the exponent.
All right,
You know.
that's a real simple way.
Mm-hmm.
But I swear I messed that up. I just got all I don't know. I got it wrong, man.
I feel you. I mean, well, you know, it's something to get used to if you're not used to doing it. You know what I mean? So you got to get used to the process and the application of what you're dealing with. So if I have X, Y, and Z here, the Z is the only thing that's affected. But here, X, Y, and Z are affected because of the parentheses. Or if I wanted to do it this way, only X and Y are affected. The X is, I mean Y and Z, excuse me. Only the Y and Z are affected because of the parentheses, the X isn't. You see what I mean? So it's all about parentheses and what's in the parentheses. And if you don't see anything in the parentheses, the only thing that's affected is the thing that's right up against it. Yeah.
I'm gonna take that with me. I appreciate you.
Mm-hmm. All right. All right. Anything else? Anybody else before we close? Everybody good? All right. So you guys have a good one. Be safe. And I will see you next class when we do more graphing. All right. Take care.
Appreciate you, bro.
No problem.
And I looked at that video you posted too, man. I'm
Okay.
surprised somebody had riffs and tips about you. You've been the best teacher I've ever seen. You know what I mean? I ain't trying to hype nothing.
Right,
I'm just
right.
being for real.
I
Like
appreciate it, man.
like I told you today with the graph and stuff. Like that would have took somebody 6 months to break down to me before. Just being real.
Right,
But I feel like I can go right from what I learned today and complete the assignments and know what I'm doing. So you doing what you're supposed to do.
I appreciate
Can't please
you,
everybody though, you know what I mean?
Yeah, it happens. Yeah. Thank you, Ms. Williams.
Yep.
Thank you.
Yep.
Thanks,
Take
sir.
it easy,
I
bro.
appreciate you. Yeah, man. Appreciate it. Anybody else before we close? Everybody good? All right. You guys have a good one.